Number 5, find the integral of x raised to 4 minus 3x squared plus 1 times dx from negative 2 to 2. Our upper limit is positive 2 and our lower limit is negative 2. In this case, we apply either theorem number 6 or theorem number 7. So therefore, we need to determine first if the given function is an odd or even function. Remember, the function is an even function if and only if the right-hand side of the equation does not change sign even if x is replaced with negative x. On the other hand, the function is an odd function if and only if every term in the right-hand side of the equation changes sign if x is replaced by negative x. Therefore, let us determine if x raised to 4 minus 3x squared plus 1 is an odd or even function by replacing x with negative x. So we have f of x equals x raised to 4 minus 3x squared plus 1. Replace x with the negative x. So this will become negative x raised to 4 minus 3 times negative x raised to 2 plus 1 equals, what's negative x raised to 4? Negative times negative is positive times negative. So positive times negative is negative times negative. So negative times negative is positive. So negative x raised to 4 is equal to positive x raised to 4 minus 3 times negative x squared. Negative x times negative x is positive x. So we just copy 3 times x raised to 2, then plus 1. Since the right-hand side of the equation did not change sign when x was replaced by negative x, we still have positive x raised to 4, negative 3x squared, and plus 1. F of x is an even function. Therefore, we apply theorem number 6, which is equal to 2 times the integral of a, then 0. So our a is 2, the upper limit, then the lower limit becomes 0. Then copy the function x raised to 4 minus 3x squared plus 1 times dx. But remember, we need to solve for the indefinite integral first of x raised to 4 minus 3x squared plus 1 times dx. So let us solve the integral of x raised to 4 minus 3x squared plus 1 times dx. Integrate each term separately. So first, find the integral of x raised to 4 dx by applying power rule. So we have x raised to n plus 1. Our n is 4. 4 plus 1 is 5. All over 4 plus 1 is 5. Minus, we have a constant. We take the constant out of the integral first. Then find the integral of x squared dx. Again, apply power rule where our n is 2. So 2 plus 1 is 3 over 2 plus 1 is 3. Plus 1 times the integral of dx. Remember, the integral of dx is just x. So 1 times x is x. Then plus c. We simplify. We cross out 3. That's why the integral is x raised to 5 over 5 minus x cubed plus x plus c. Then, we copy x raised to 5 over 5 minus x cubed plus x, omitting c, since c is not important in evaluating the definite integral. So we copy 2, then x raised to 5 over 5 minus x cubed plus x. Then copy the value of our upper limit, which is 2, and our lower limit, which is 0. Then apply the fundamental theorem of calculus. So this is equal to 2. Replace x with the value of b, which is 2. So we have 2 raised to 5 over 5 minus 2 raised to 3 plus 2 minus, replace now x with the value of a, which is 0, the lower limit. So 0 raised to 5 over 5 minus 0 cubed plus 0. Then simplify, we copy 2 times 2 raised to 5 is 32 over 5 minus 2 raised to 3 is 8 plus 2 minus 0 raised to 5 is 0 divide 5, 0 minus 0 cubed 0 plus 0 is 0. So this is 2 times 32 over 5 minus 8 plus 2 is 6. Copy 2 times what is 32 over 5 minus 6. 5 times 6 is 30. So 32 minus 30 is 2. Copy the denominator 5. Again, 32 over 5 minus 6. 5 times 6 is 30 minus 32 is 2 over 5. 5 times 6, 30. 32 minus 30 is 2. Then copy the denominator 5. So this is equal to 2 times 2 is 4 over 5. And this is the integral or the definite integral of x raised to 4 minus 3x squared plus 1 times dx. For problem number 6, we have the integral of x cubed minus 4x times dx from negative 2 to 2. And again, our upper limit is positive 2 and our lower limit is negative 2. We apply either theorem number 6 or theorem number 7. We need to determine first if x cubed minus 4x is an odd or even function. So to determine if the given function is odd or even, we replace x with negative x. So our function is x cubed minus 4x. Replace x with negative x. So negative x raised to 3 minus 4 times negative x. So negative times negative times negative is equal to negative x cubed. Negative times negative, positive. Positive times negative is negative. Then, negative 4 times negative x is positive 4x. Since the terms change sign when x was replaced by negative x, from positive x cubed became negative x cubed, from negative 4x became positive 4x, we can say that x cubed minus 4x is an odd function. Remember, it is odd function if every term in the right-hand side of the equation changes sign if x is replaced by negative x. Therefore, we apply theorem number 7. The definite integral of an odd function is equal to 0. Since x cubed minus 4x is an odd function, therefore the integral is equal to 0. So that's how you solve for the definite integrals. Apply the rules or theorems, then remember, to evaluate a definite integral, we need to find the indefinite integral first and then use the fundamental theorem of calculus. The evaluation of definite integrals still needs a good command of basic antidifferentiation techniques. Remember also that the constant of integration doesn't matter when we are evaluating the definite integral.